Hello again. Alright guys, so we're back talking about systems of equations, and this video is going to focus on the application problems. Okay, so we're kind of finishing out this whole idea of systems. I would like to work on problem number 17 and 18 in this video. If we go up to the directions here, it says solve the system of equations application problem using your choice of substitution or elimination. Okay, so you guys get to choose based on what you have in front of you and what you feel is going to be the easiest for you. Okay, so remember that these are systems of equations, applications. So system, the word system means more than one. So we know that in the end here, we are going to come up with two equations that we are going to need to solve and get some ordered pair for. Okay, so just kind of knowing what to expect when we go into this is helpful in terms of how we go about working this. All right, so and every problem is different, we just kind of have to take what's in front of us and try to remember what we know about these types of application problems. All right, so let's start on number 17. Let B equal Bob's age in years. Oh, that's helpful. They've already helped us to define some of our variables here. So B is equal to Bob's age in years, and R is equal to Rachel's age in years. The sum of their ages, B plus R, is 120 years. The difference in their ages, B minus R, is 10 years. How old are Bob and Rachel? Okay, so there's some good information in here that we are definitely going to use. Let's just take this one. We know that that is going to be true, and this is going to be true. So this is kind of a nice problem because it's helped us a lot already with some of the stuff that we would normally need to pull out of, the problem and kind of set it up. Okay, so I know basically I have to come up with those two equations or two categories. In this particular problem, I don't really even need to worry about the categories because it really helps me already. The two categories basically are a sum of their ages and a difference of their ages. So I've got my two equations. Here's my sum, and here's my difference. Okay. Now, we know that our next step, this is kind of steps 1 and 2, where we're we're getting to know what the problem is saying. We're writing our knowns. These, of course, here are unknowns, right? And you don't have to relist those, especially if it's helpful. It's helpful if you do that, but since they're already listed here in the problem, you don't need to do that. All right, so we need to come up with we need to solve these two equations. And I want you guys to notice that our B and our R are on the same side of the equation for both of these. So in my opinion, this is set up really, really well for elimination method. Okay, you can choose to do substitution if you'd like to. It doesn't really matter. All right, so I'm going to go bring this over here. So we've got B plus R. I'm just rewriting this. It's 120. B minus R is equal to 10. Okay, I'm going to add these. You can see right away that we have our R's right here are opposite terms, right? So those are going to go out very nicely for us already without doing anything. All right, so we've got 2B is equal to 130. Therefore, B is equal to 65. Okay, and of course, we're going to plug that value in for B so that we can solve for R. So if we say, all right, here we go. I know that B is 65, right? So instead of B up here, I'm going to write 65 plus R. I'm just bringing this guy over. Equals 120. and therefore R is equal to 55. Okay, so if we go back up here and we remind ourselves what the question asks, how old are Bob and Rachel? Well, we've pretty much covered that, haven't we? So we know that Bob is 65 years old and Rachel is 55 years old. Now, you would want to make sure you plug those back in. Right, remember, we always do that check. Okay, that's a part of the 6-step problem-solving process. So, of course, we would just plug those values back in and double check. And I'll let you guys kind of work on that. That would be a pretty easy thing to even visualize and see that that would definitely work. All right, let's take a look at number 18. So Whitney has a coin jar with a small collection of nickels and dimes. There are 32 coins in the jar. They have a total value of $1.95. How many nickels and dimes are in the jar? All right, so we have a little more work to do on this one, but no worries, we can handle it. I always like to start defining my unknowns. All right, so let's do some highlighting here. So we know we have nickels and we have dimes. Okay, I'm going to just go ahead and continue with highlighting a few things. We've got 32 total coins and we have a total value here of $1.95. And you notice that the question asks us how many nickels and dimes are in the jar. So this is what it's asking for. This is what our unknowns need to be. Okay, so if you're ever wondering how do I start defining this, you can see up here our unknowns were, you know, Bob's age and Rachel's age, because that's what we were asked to do in the problem, the question we were asked to answer. All right, so I'm just going to use N for nickels and D for dimes. Sometimes it's helpful to use the variable that stands for what you're talking about, just so when you're done, you know what you just solved for. All right, so this is one of those problems where we really need to come up with our categories ourselves. The other one did it for us, the number 17, they did that for us. So, oops, not two knowns. Can't talk and write at the same time. Knowns. And what we're really doing here with our knowns is we're looking for our two categories. So we go back up to the problem and we can see we have this total number of coins and then we also have a money value, don't we? So let's go ahead and list our two categories. So total coins, we're going to come up with an equation, and a total value, which of course is in terms of money. All right, so with total number of coins, all I'm really going to be doing is adding my nickels plus my dimes, and I know that in the end that has to be 32 coins. So there's my first equation. And remember how we talked in one of the other videos about one of these categories are going to be weighted, right? And money is always weighted, of course, we know that. Okay, so we're going to have to weight these. Now, we know that nickels are worth 5 cents. So we're going to weight this nickel at 0.05. And of course, dimes are worth 10 cents. And then, of course, we have a total value of $1.95. Okay, so here is our second equation based on our two categories. All right, guys, so now oopsie, I forgot the D here. D, there we go. Oh, no, I didn't. That was, oh my goodness. Oh, boy. There we go. I hadn't forgotten anything. You guys can see that these two equations now might be set up a lot easier for substitution because we have decimals. We have decimals in there, and that's going to be really hard to kind of multiply that first equation by either a negative 0.05 or a negative 0.1. It's kind of a nightmare. So what I would like to do then is to take this equation here, and we would like to rewrite this, right? Let's rewrite this in terms of n, okay? So all we're going to really need to do here is, in fact, I can just do it right down in here. Let's minus d from both sides, right? And then we're going to get n is equal to negative d plus 32. Okay. In fact, I'm going to run out of room. Just this is at the bottom, so I'm going to just write this right above. N is equal to negative d plus 32. All right, so therefore we now have this value that we can stick in, and in fact, you know, if I know that we usually put the value, you know, the variables first, but we could also write this as just 32 minus d. I think that's actually even easier, so I'm going to do that, 32 minus d. All right, so we have solved that equation in terms of n. And so all we really need to do now is just plug that value in. I'm going to go to my other equation here, 0.05, and instead of my n, I'm going to plug in this value here of 32 minus d. Plus 0.10d. 1.95. Now everything is in terms of d, which is helpful. And we just have a little bit of distributing to do here. So 0.05 times 32 is going to give me 1.6 minus 0.05d. All right, and so we're going to combine our like terms here. Okay, if we've got a negative 0.05, basically plus 1d, that's going to give me a 0.05d. I still have this 1.6. Let me redo that. And let's subtract our 1.6 from both sides. .95 minus 1.6 going to give me 0.35. This is kind of icky because we have a bunch of decimals, but you guys can use your calculators, no problemo. Okay, so we have d is equal to 7. So we have solved for the number of dimes, obviously, right? And then we can just easily plug this in. We know that now d is equal to 7. That's helpful, right? So let's go back to our equation here and just solve that, or solve for n by just plugging in 32 minus 7. So our n is equal to 25. Okay, so we know that we've got 25 nickels and we have 7 dimes. We can easily see if we add those together, 25 plus 7 is going to give me 32, right? So that actually works. We want to make sure we plug those back into both of these equations. We're going to plug the n and the d back into both of those equations just to make sure that that works. All right, guys, so that was an example of both methods, like the elimination method and the substitution method. I think that I would say number 21 would be a good one for you guys to practice. That's actually a very important problem. I'll just kind of hint to you there. Okay, number 21. So pay close attention to this type of problem. You got lots of them on there. I'd really like you to practice those. Just get, if you just practice them enough, after you've done 5 or 6 or 7 of those, you start to feel a lot more confident, right? So I'm not going to do this problem, and I'm going to just kind of help break down this problem a little bit. Okay, got a theater that sold 1,125 tickets for a musical performance. The orchestra seats cost $40 each, and balcony seats cost $25 each. The theater collected $39,000 in ticket sales for the performance. How many orchestra tickets were sold? Okay, so we've got orchestra seats and we have balcony seats, right? These are our two unknowns. Okay, we need to make sure that we define those. Whether you want to say O is orchestra and B is balcony, or use an X and a Y, you definitely want to define those. Thinking in terms of categories, you can see here we've got a total number of tickets. This is just items, right? This just looks like a number of tickets. And we have a total, let's just do it this way, a total in sales, right? This is our sales. Okay, so when we start to think about our two categories, we've got a number of tickets and we have sales, don't we? Right, that's 1 and that's 2. Now, when we start thinking about our weighting, we have to weight one of the categories. Looks like we're going to be weighting our O's or our X's, whatever you use, at 40. And we're going to be weighting our balconies by 25. Okay, so that's kind of how we're breaking down that information and coming up with our two equations. And then you guys get to choose whether to use elimination or substitution. Okay, guys, please feel free to use those solutions to help guide you, okay? That I think sometimes is helpful when especially on these types of problems. All right, guys, thank you, and talk to you